The diagram shows the design plans of a sail. EG is a straight line, HX is 64 feet, XG is 41 feet, and angle HEX is 48 degrees. So here we have the diagram, and here they want us to calculate correct to the nearest whole number, the length HG. Now notice here, this is the length AG, and if you notice that this right here is a right angle triangle. Now we know that this is a right angle triangle because here, this is 90 degrees. And so if this part here is 90 degrees, this part here must also be 90 degrees because angles on a straight line add up to 180 degrees. So this is 90, this is 90, they both add up to 180. So we're dealing with a right angle triangle. And so what we have here is we can use the Pythagoras theorem, right? And so the Pythagoras theorem tells us that c squared is equal to a squared plus b squared. And so what we have here is we have that a is going to be equal to, well, a is 64. We have that b is 41. And we have that c is the missing angle. That's the hypotenuse. C is the missing side, I should say, which is the hypotenuse. All right, so we have the missing side. And so that's what we're trying to find. And so let's do this. So we have c squared. We know that a is 64. We know that b is 41. And so we have 64 squared plus 41 squared. And so what is 64 squared? That's going to be 4,096. What is 41 squared? That's 1,681. And so we have c squared is equal to this sum. So we add it. And so it's going to be c squared is equal to 5,777. And so we're going to take the square root of both sides, cancel this with that. And so we are left with c is equal to 76.00657,866. Now they say to express our answer correct to the nearest whole number. And so this is going to be, notice that this number right here is 0. It's less than 5, so that means that we cannot round up. And so we are left with just with 76. And so that means that HG is going to be 76 feet. So that's the answer right there for this one. HG is 76 feet. And that's the answer right there. HG is 76 feet. Next, we have to determine the size or the measure of angle G. Now we are concentrating on the angle that's in the middle, which is G. So we have X, G, H. And so we're looking at X. So this is X, this is G, and this is H. All right. So we're looking in particular about this angle right at this angle, this missing angle, angle G is what we're looking for. So this is theta. And in order to find this missing angle right here, theta, what we have to do is we have to use, or what we're going to do is we're going to use this acronym, which is SOHCAHTOA. And so let's first label our sides. So this side that is opposite the angle, that's the opposite side. All right, this side that is opposite the angle is the opposite side. This side that is opposite the right angle, that's the hypotenuse, which is the longer side, which we just saw. And 41 is the adjacent, right? That's the adjacent side. And so our goal is to determine what is the angle, what is the size of angle G. Now we have the opposite side, we have the hypotenuse and we have the adjacent. We could use any one of the trig ratios. So we could use sine, we could use cosine, or we could use tangent because we have all three of the sides. All right, I'm going to use tangent. All right, I'm going to use tangent. And so we have tan of theta is going to be equal to the opposite over the adjacent. And so I'm going to use 64 and 41. And the reason why I use tan theta, the reason why I use that is because I want to avoid using the answer that we just figured out recently. I want to use the sides that they gave us. All right, now you can use it, but I want to use, now you can use this side and use a different trig ratio, but I want to use tan theta because that incorporates the opposite and the adjacent, the sides that were actually given. Okay, and so we have tan theta is equal to 64 over 41. Remember, the opposite is 64 and the adjacent is 41. So we have 64 over 41. Next, we have to remember our goal. Notice that our goal is to find what theta is. All right, so that's what we're trying to find. We're trying to find out what theta is. And so we have to take tan inverse of both sides. And so we take tan inverse of tan theta and tan inverse of 64 over 41. And so we cancel out this tan inverse with this tan. And so we are left with theta is equal to tan inverse of 64 over 41. And so that means that when we take the tan inverse of this quotient, or when we take the tan inverse of 64 over 41, we get that theta is going to be equal to 57.355,35987. But we want to write our answer correct to the nearest whole number. So we look at this number, 3. 3 is less than 5, so that means that we cannot round up. So that means that our answer here, theta is 57 degrees. That means that angle XGH, this angle right there, is 57 degrees. Next, it tells us to calculate to correct to the nearest whole number, the length EG, the length EG. Now, what is the length EG? Well, the length EG is this entire length right here. That's the length EG. All right, that's the length EG. Now, the thing is, we already know that XG is 41 feet. The only thing that we really need to figure out is what is the length EX. And once we figure out what is the length EX, then we can add that length to XG to get the length EG. And so what we're going to do right now is determine how we're going to get EX, how we're going to get this length. We know that this here, theta, is 48 degrees, and the opposite side is going to be 64 feet. We also know is that this is a right angle, and so that this is the hypotenuse. So this side is the hypotenuse, and this side is the adjacent. What we need to find is what is the adjacent side. We need EX. And so that's what we're gonna do. So we have tan theta. Now, why do we choose tan theta? It's important to know why do we choose tan theta. We chose tan theta as opposed to sine theta and cosine theta because we have the opposite side, which is 64 feet, and tan theta incorporates the opposite side, and we're looking for the adjacent side. And so that's why, and tan theta incorporates the adjacent side. So that's why we use tan theta, because we are looking for the opposite, and we have the opposite, and we are looking for the adjacent side. And so we have tan theta. Now we already know what theta is. Theta is 48 degrees. So it's going to be tan of 48 degrees is equal to 64, which is the opposite side, all over x. Now we say x because that's the missing side, EX, right? What are we trying to find? That's the adjacent side that we're trying to find. So we put x at the bottom. Next, we're going to put tan of 48 over 1. And it's going to be tan of 48 over 1, which is equal to 64 over x. We cross multiply. So we take tan of 48, and we take x and we multiply that by tan of 48, and we take 1 and we multiply that by 64. And so we have that x times tan of 48 is equal to 64. We still need to figure out what is x. And so I'm going to divide both sides of this by tan of 48. And so this cancel with this. And so we're left with x is equal to 64 over tan of 48. And when you do 64 divided by tan of 48, you get 57.62585884. And that's what x is, right? That is what the length EX is. But we're not done because we need to find the length EG. All right, we need to find the length EG. So all we need to do is add the length EX, which we just figured out, which is 57 point, all those decimals, plus EXG, which is 41. And when we add them, we can get EG. So EG is going to be 57.62585. It's going to be 57. EG is going to be 57.625858884 plus 41. So when we add them, we get 98.625858884. But we want to correct to the nearest whole number. And so we have to round. And so notice that this right here, This right here is 6. Once it's 5 or greater, we round up. That means that we're going to add 1 to 8. And when we add 1 to 8, we get 99. And so that means that the length EG is 99 feet. And that's the answer to this question, 99 feet.